Okay, so we want to learn about the levels of learning really quick here. So what we see here, this is called Bloom's taxonomy of learning. So you can see the lowest level learning is just remembering. So you just memorize a list and you just give that back on an exam. The next thing is understanding, and that's understanding what those things that you memorized actually mean. The next level is taking that understanding and applying it to a problem to do something. Like what principle do you use? And then you're going to analyze a problem. And then after analyzing a problem, then comes this creating and evaluating, which is more like design. So in engineering, these top two here we call design. This we call analyzing. So in most classes, we spend a lot of time analyzing. And we want to get to the point as an engineer to be able to do this creating and or designing. So in order to understand how all this works, let's apply this to a simple problem. So we're going to practice this progression of learning with an in-class assignment. So you should all have an in-class assignment that we're going to work together. So we're going to be doing this on batteries. So here is a lithium ion battery. We're going to be using this Samsung 21700 battery. So you look up the specs here and you see that it has a nominal voltage of 3.6 volts. It actually varies from 4.2 to 3. We're just going to assume that it's 3.6 volts. It has a cell capacity of 4,000 milliamp hours or 4 amp hours. And so that's how much energy it has in terms of current. It has a max continuous current of 35 amps. So let's go over to our activity and start. So we want to start with, let's go over here. So we want to start with this idea of remembering, understanding, and applying related to this problem. So we go over here and understanding is Ohm's law. Well, we're going to start with memorizing. So what is Ohm's law? So Ohm's law is, let's go with blue, is V equals IR. So that is, we're understanding, we memorized Ohm's law. And so I remember, oh, someone says, what is Ohm's law? You say V equals IR. So then you're into applying. Well, what does Ohm's law mean? How do you use it? So when would you use Ohm's law? And so we come in here and we say to get voltage and current using resistance. Great, so now we understand, we applied Ohm's law. So now we're going to go up to the next level. So now we want to get into this analyzing part. So we're going to come in here and we are going to grab our next part. Okay, so if you were in 240 and you were asked, oh, analyzing. So a lithium ion battery is modeled as a 3.6 volt source in series with a zero point 0.1 ohm resistor. So that is the specs of our problem. So we want to know what is the maximum power that it can supply. So here we come in, let's draw what we have. So we have a 3.6 volt battery. We have a 0.1 ohm resistor right here. And the question is, how much power can it provide? Well, if I came in here and put a short right there, and we're trying to find out how much power is consumed in the load. Well, it has 0 volts, so power is equal to voltage times current. Voltage times current, so that's going to be 0 volts times, oh, a whole bunch of current. Well, who cares? So if it puts out 40 amps, that's going to be 0 volts. So how do I get the maximum power that it can provide? So the maximum power, oh, this is a maximum power problem. So a maximum power problem, I want V of my supply to be equal to R of my supply to be R of my load. So I'm going to put in a 0.1 ohm resistor. So what is the resistance of the load? 0.1 ohms. What is my maximum power? So power equals V squared over R. The voltage we're going to get, this is a voltage divider. So again, we're understanding and applying my voltage divider that I learned from 240. And so this is going to be 1.8 volts squared divided by 0.1. So that comes out to 32.4 watts. So that's the maximum power that a single battery can put out. Okay, so now we've analyzed a problem. So analyzing a problem was, here's a problem, solve it. So now we're going to get into the next thing. So the next thing is, this problem asks, a Tesla 3, which is one of the cool electric cars, has the following specifications from the battery. So some marketing person came along and said, I need a battery that has 75 kilowatt hour capacity. I need a maximum discharge rate of 1200 amps and 340 volts, and we need this in order to meet the speed and distance requirements. So now we are on this evaluating and creating. So we have a single battery, but the battery doesn't meet the specs. What do? So you have to come up with a combination of batteries that's going to meet these specs. So let's grab this part. See if I can pull this down. Okay, so we have to create our battery pack that has a much higher voltage and a much higher current than this part right here. So let's start. So then we have to say, okay, well, I'm going to have to put these into series and parallel combinations. Well, let's start with series. So when I have two voltages in series, then the voltages are going to add. So I'm going to have a structure that looks like this. You know, dot, dot, dot. And then we're trying to measure what is the voltage across here. Well, this is an open circuit. There's no voltage drop across my 0.1 ohm resistor. So then I'm going to have 3.6 volts times some number of batteries in series is going to be equal to 350 volts. So we see that N is equal to 350 over 3.6, which is equal to 97.2. So we're going to use 98 batteries in series. Okay, so what does this total thing look like? And so now here is our new battery pack. So this is going to be 98 times my 0.1. So this is going to be 9.8 ohms. And then I have 350, I have 3.6 times 98. And so this is going to be 352.8 volts. So this is my battery pack. So now we're going to go back to our applying. So what is our maximum power? So now our maximum power, or let's look at our maximum current, is going to be if I have a short. So I'm going to have 352.8 volts divided by 9.8 ohms. So this can put out 36 amps. Well, 36 amps isn't enough. We need 1200 amps. So now I need more current. So what am I going to do? Well, I look at this, and again, I'm going to use some of the principles I had in 340. I want to convert this into a current source. So I'm going to use a current transformation. Which looks like this. And so then you see this is going to be 36 amps. And this is going to be 9.8 ohms. So now what I want to do is now I'm going to come in here and I'm going to add another one of these battery packs. And I'm going to add those in parallel. So when I add those in parallel, I can see that these two current sources are going to add together. So then I'm going to have a set of current sources added together and a bunch of resistors that are in parallel. So now I come in here, and so now I have 36 times M, which is going to be the number in parallel, should be equal to my 1200. So now I have M equals, and I'm going to take 1200 divided by 36. So this is equal to 33.3. So I'm going to use 34. So now let's look at what this is going to look like. So now I'm going to have all of these in parallel. I'm going to add up my current. So now my current is going to be 34 times 36. So this is 1, 2, 2, 4. And then I am going to have 9.8 in parallel with 9.8. I'm going to have 34 of those in parallel. So I have 9.8 divided by the 34. So this has a resistance of 0.288 ohms. And that is my combined parallel one. Okay, so my design, let's write down what our final answer is. We have 98 in series. And then those combinations have 34 in parallel. Okay, so let's see where we are at. So now we basically created our new battery pack. So our new battery pack has a bunch of batteries in series and parallel. We have the right combination in series and parallel to get it to work out. So let's kind of review what we did. So we were evaluating, creating, using these batteries. We wanted to create this combination. Okay, so we have a max current of like 12. We have a max current of 1224, and we had a max voltage of 352. So it met those specs. We wanted to check our capacity. Okay, so let's go and check our capacity. So we want to see how much capacity you have for each. So let's go with one battery. Which was 4 amp hours times 3.6 volts. So this is 4 times 3.6. So this is equal to 14.4 watt hours. Okay, now we have 98 times 34 times 1.44. 98 and 34. So we have 48 kilowatt hours. Okay, so this capacity is actually a little bit less, and so we would have to increase our number of batteries to get it a little bit higher. So what we see here in this design, in order to meet the current and the voltages, we needed 332 batteries. Here's our one battery. So we see actually to get to the 75 kilowatt hours, we would need 5,200, which means that we'd even get more current. Okay, so now let's look at what our Okay, so there was off a little bit, so now we have to find the maximum power. So let's go and calculate our maximum power. So you see here is our basic circuit, and so in order to get maximum power, we're just going to come in and we're going to add in the same resistance. We'll go ahead and leave it in current. We could have converted it back to voltage. We would get the same answer. So this is 1224, and this is 0.288 ohms. We are going to put a matched load to get maximum power transfer, 0.288 ohms. And so my power is going to be I squared R, which is going to be 1224 squared times 0.144, which is equal to 216 kilowatts. Just to get an idea what this means, so a residential house has a 240 volts coming into it, and a typical house has a maximum of 100 amps. So your total house can only supply 24 kilowatts of power. The battery pack for this car is like 10 houses, the equivalent power of 10 houses, just to get you the idea of how much power can be delivered by these batteries into these cars. So let's kind of finish this up for fun and let's go look at it. So here's the Tesla 3 battery. So you see they have four of these packs. And these packs, I don't know if they're in series or parallel. I would guess that each of these packs are in parallel. So if we go inside these packs, you see each of these packs is built up with a whole bunch of these batteries. So they have all these batteries that are kind of glued together. You can see here is the connection on the top. They have another one of these on the bottom to get the right combination of series and parallel to get everything to work. And they're all glued together, and then they use these strips sections in between in order for heat dissipation to get it to work. And so then you have this fancy battery